Harmonic Motion, and today we're going to deal with phasors and energies in SHM. Now, what an introduction it was yesterday, and what a lovely session. We saw so many graphs, simulations on Desmos, the graphing calculator. So let me tell you guys, SHM or oscillations are there everywhere around us. Like for example, look at the structure of a benzene molecule. Look at that. Even they are vibrating. Not just benzene, in fact, every molecule, if you look at it in an electron microscope or if you try and model it, there will be lots and lots of vibrations in it. You can see that, how beautifully they are vibrating. In fact, even the wings of an airplane vibrate, and if you have traveled and sat near the wing in the window seat, you would have definitely seen the wing vibrate. Oscillations are there everywhere around us. Look at this beautiful drop of water and see what happens when it is poked using a pointed object. Look at the waves, look at the oscillations, look at those vibrations. So oscillations are there everywhere around us, and they form really beautiful patterns when they happen periodically. Wow, how beautiful it is. So let's talk more about it. Welcome guys, welcome aboard. This is Shreyas here, your master teacher for physics at Vedantu, and also the anchor for this channel for Enthuse. So welcome first of all. Hello Sunil, Krito, Dinesh, Jumna, Asmi, Akansha, Ira, 17S, Science Priya, Yalni. Hello everyone. Hello Minion Aarti. Hello everyone. Hello. So hello Khushbu. Hello Delhi. So those of you who are new to this session, let me quickly introduce myself. So guys, I am Shreyas and I teach physics not just on YouTube but also the regular long-term batches. And before this, I have been teaching in offline coaching institutes for a very long time. And during my tenure of teaching, I have produced some amazing ranks, and I hope to do the same with you. Many of my students, like you can see, are right now in IITs, IISc, ISERs, and all the other top-notch institutes of our country, and some of them are even abroad. So I really hope you feel motivated, and I really hope I instill that love for physics and that fear for physics goes away learning from me. So welcome everyone. Hello Vishnu. Hello everyone. Hello. Yes. So don't worry Vishnu, if you even start today, you can still clear JEE 2021 as long as you watch all the lectures properly, and if you follow and if you are consistent, definitely Vishnu, you can clear, and it is going to happen. Don't worry. Hi Laltan. Hello Khushija. Hi Vishwajit. Alright. So before I forget, guys, remember you can watch the amazing stuff. You can tag me in different posts on Instagram. That's my Instagram handle, Shreyas_Vedantu. So you can get in touch with me over there. And also do not forget to hit the subscribe button in case you are new for this channel. And if you are already subscribed, guys, you should smash that like button, because remember, your likes is the only fees for this channel and my lectures. So come on, go ahead, start hitting that like button if you have not done it already. Okay, so let's see the timetable for this week. See, we have started with KVPY session on fluids and errors. We started with SHM yesterday, that was lecture 1. Today is phasors and energy. Tomorrow, remember, the lecture is at 2 o'clock. Be careful, it's at 2 o'clock. So guys, do not miss the live session. And again, I will be seeing you in the evening at 5:50, guys. 5:50 p.m. Yes, that's going to be the live streaming session with our education minister, Ramesh Pokhriyal. He's going to announce finally the dates for the 2021 CBSE examinations. So board examinations dates announcements, a live streaming session in the evening, and that's it. And I'll be meeting you next year, Saturday, for a marathon session on magnetism. Alright, and the Menti quizzes are going to be this time only for maths and chemistry. So chemistry Menti quiz on Sunday, do not forget to attend that. In case you have missed the maths Menti, do not forget to check the replay. Alright, so let's begin guys. I hope the josh is high. I can see a lot of crowd. Very good. Hello Shreya, hello Deya, hello Dinesh, hello Tragic. Are Tragic, you changed your name, or are you, Jumna, are you logged in from 2 accounts? Hi Sneha. Hi Tech Tamil, welcome. Yes, the Josh is high. Very good, very good, very good, very good. Chalo, let's begin then. Let's begin. So, guys, also check all the important notifications on our Telegram group. Okay, in case you have not joined it yet, please check it out. All the important details, PDFs, assignments, solutions will be shared on Telegram group. So do not forget that. Now, last lecture, I have told you that any particle which oscillates back and forth, all right. So we have seen this. Any particle which oscillates back and forth such that the force is proportional to x and the constant is k is going to perform a SHM. The restoring force, the force which brings it back, opposing the displacement from the equilibrium or the mean position, is related by F is equal to minus kx. Remember that? We have talked about this. Now we have also seen the equation of SHM. Equation of SHM was A sine omega t plus phi, where A was your amplitude. Remember how far it goes on the left and right. Omega was 2 pi f, where f is your frequency and omega was your angular frequency. This phi was nothing but your initial phase angle. Alright, so this was your initial phase angle, that's what you have seen. And we have talked about velocity, we have talked about acceleration and so many other important formulas in our previous session. Now, this was a brief recap of what we have done last lecture. Now, is there some kind of relationship between simple harmonic motion and uniform circular motion? And the answer is yes. And the answer is yes. And let's see what is the relationship. Now, if you look at this beautiful simulation, you would definitely understand this. Look at this block. It's going up and down, it's performing simple harmonic motion. Look at this particular object over here, is going in a circular path. In fact, it's performing uniform circular motion. If you notice, if I have some rays of light coming from your left towards your right, all right, or let's say from the right to the left. So if rays of light come from here and go over there, understand the shadow of this green particle on a wall which is here, the shadow of that green particle on this vertical wall will perform a SHM. You can see that. So if you look only at the y coordinate, look at only the y coordinate. So look at that, only that y coordinate is performing SHM. So if light is falling from one side and you are seeing the shadow of a particle performing uniform circular motion on that wall, that shadow performs uniform circular motion. Interesting, isn't it? I hope this is clear. Vishnu, please don't spam, you will get banned from the channel. Be careful. Put your questions only once, remember that. Yes, interesting. Now, let's see how exactly it is related, because not many people discuss many things about it. And remember, phasor diagrams is very important because it will come not only in SHM but also in waves, in sound waves, transverse waves, and in the next year 12th standard also it is very important. AC waves, etc. They all have phasor diagrams in that. So what is this phasor diagram and all these things? So let's see what is the exact relationship. So let me just create a diagram for all of you. So just imagine, guys, just imagine. Okay, so let's take a circle. Okay, let's just draw a circle, and okay, this is my horizontal line, and this is my vertical line over here, and here also I'll draw another horizontal line. Okay, and okay, so this is my mean position. Okay, so let's start seeing what exactly this is. So on the top I have drawn a circle. Okay, this dotted line is the x-axis, the vertical line, the solid line is the y-axis. A similar dotted line has been drawn here with the y-axis. Now just imagine there is a particle which is going along this circle with constant speed. Okay, so let's just say that initially, okay, let's just say initially that the particle was maybe, okay, over here. So this is where the particle was initially at t is equal to 0, and I'm going to call this vertical line as my reference line. What am I going to call it as? I'm going to call it as my reference line. Very important, keep making notes, very, very important. The angle which it makes initially, this particle with my reference line, this angle is going to be called as phi. What am I calling it as? Phi, the angle which it makes with the reference line. Now remember, this particle is performing uniform circular motion. It's performing uniform circular motion with constant angular velocity omega. Everybody understanding this? Everybody understanding this? Very good. Now think about it. In some time, what is going to happen, guys? This particle is going to go somewhere else. It's going to probably reach over here, and this is going to be at some value of t, some instant of time t. So earlier, first it was here, it has displaced by some angle in some interval of time t. This angle which it covers, how much will it be? Think about it. Angular displacement will be angular velocity multiplied by the time taken. Angular displacement is angular velocity into the time taken. So guys, won't it be omega into t? Correct? Isn't it going to be omega into t? Yes, we are starting from the y-axis just for convenience. You will see why I'm starting. You can start it from x-axis also. Alright, Shreyan, remember this is flash series, okay? So if I teach everything over here, understand, then the syllabus will get completed next year. Number one. Number two, if you want to learn everything in detail, all the derivations of center of mass, there is a micro course which I am running in the pro subscription. You can definitely attend that. All the things have been derived over there, my dear friend. Okay, so watch that. You will definitely get all the details in the micro course which I am conducting. Okay, I hope that answers your question. Okay, so now here is the thing. Imagine I now draw a perpendicular from here. Okay, I draw a perpendicular from here, and I just see what is the length on the x-axis. So I'm just saying what is the length on the x-axis from here till here. So guys, that length I'm just going to call it as x. That length I'm just going to call it as x. Now think about it. In this right angle triangle that you can see over here, I hope you can also visualize what is this angle going to be. Guys, these are two parallel lines. That green line and that black dotted line, they are parallel lines, and there is a line over here, and this angle totally is phi plus omega t. This angle is phi plus omega t. So what will this angle be? Won't this angle also be equal to phi plus omega t? I hope you can see that. I hope everybody can see that. Think about it. It's phi plus omega t. Can you see that, guys? Everyone? Is everybody able to see that? Yes? Very good. These are two parallel lines. There is a perpendicular over here. So guys, now think about it. What will be the value of x if the radius of that circle, so let's say that the radius, okay, the radius is going to be a, some a is a constant. So what will be the value of x? The value of x, because it is opposite to that angle, all right, in this right angle triangle, will be hypotenuse, which is a, sine of that angle omega t plus phi. Do you see that? Do you see that? Yes, I will definitely launch, Rohit. That will be next year. Definitely, we will launch next year by month of April. Correct. Now, what is this equation? This equation will be nothing but SHM ka equation. And don't worry, Rohit, that will be an in detail series. Entire year it will run and will cover every topic properly, right? How it is taught properly. Don't worry. Remember, this is flash series. We want to cover everything before your exams, remember that. So if I extend this black dotted line, okay, over here, this black dotted line over here like this, okay, it will cut over here somewhere, and then this thing is nothing but x. And so if I have a particle here, then as and when this particle in this circular motion performs UCM, you will see this particle below will perform SHM motion. That's what is going to happen. So this is the proof that the projection of a uniform circular motion is a SHM. This is SHM. I hope this is clear. Rohit, I'm saying for 11th, 12th, everything we are starting. It's not just for 11th. Understand that. Okay? I hope this is clear. Okay. So any doubt, Rohit, anything apart from the subject you have, please post it up in the comments, because I can't disturb the flow of the class. So please post it up in the comment section. I'll definitely help you out. Okay. So now, my point is, look at what phi signifies. Let's talk about the significance of phi. Now, this diagram, okay, this diagram over here, this diagram is called as the Phasor diagram. Phasor diagram. And in the Phasor diagram, what do you get? The radius is nothing but the amplitude. The radius is nothing but the amplitude. The angular speed of UCM is nothing but angular frequency of SHM. Remember, angular frequency of SHM, omega. Same omega you will get over here. So that's why the symbols are also same. And in UCM, wasn't omega equal to 2 pi by t? And same thing is also valid in SHM. That's the reason for that. That's the reason for that. And next thing, guys, what you're going to see, this initial angle, or the initial angle, is basically your phase constant. That initial angle with the reference line is obviously that phase constant that you can see. It's the phase constant. So you can see a lot of similarities over here between circular motion and uniform circular motion and simple harmonic motion. Lot of similarities. Now, what I want you to understand, let me just add one page. Second, yeah. Just imagine, again, I will draw this uniform circular motion, and then this is SHM. So, just think about it, guys. Imagine I see a particle over here and it is moving this side. This is the mean position. And this is the extreme position, and this is the other extreme position on the left side, and this is on the right side. Think about it. If initially the particle is over here at t is equal to 0, can you guys guess on the circular path where should that particle be? Where do you think that particle should be such that the shadow falls exactly over here? Just think about it. Just think about it. Where should the shadow fall? Do you think? Yes, where do you think it should be so that the shadow falls exactly over here? Come on, guys. एकदम सामने बिल्कुल यहाँ पर. Yes, exactly, it should be over here so that the shadow falls exactly here. In this situation, what will be the value of phi, guys? Can you guess what should be the value of phi? What should be the value of phi if at t is equal to 0 it was here? It should be 0, correct? Similarly, think about it. If you open your eyes and you find that initially the particle is at the rightmost extreme, you find that the particle is at the rightmost extreme at time 0 when you opened your eyes. So where will that particle be? The particle on the circular path should be over here, and here the phi value will be how much? Pi by 2, 90 degrees. So the shadow will fall exactly over here when it is at the right extreme. Similarly, if you open your eyes and figure out that the particle is at the mean but it is going towards the left side, then that particle on the circular path should be over here, and then the value of phi will be pi, because this is the complete angle pi radians 180 degrees. Remember, when that particle is here, it's going towards the left side, so the shadow will also go towards the left side. So understand, just because the particle is at mean does not mean phi is 0. You have to also check what is the direction. If it is going towards the right side, oh, then phi is 0. If it is going towards left side, then phi is pi radians. Understand that. And similarly, guys, think about it. If that particle is here when you open your eyes, that means on the circular path, the particle should be here, and that value of phi will be 3 pi by 2. I hope this is clear. I hope this is clear. So, my point is, just looking at where that particle is, I can predict the initial phase angle. And similarly, think about it, guys. Imagine I tell you that there is a particle which is performing SHM. This is mean position, this is extreme left, and this is extreme right. Just imagine if I tell you there is a particle somewhere between mean and extreme here, and it is going towards the right side initially at t is equal to 0. Guys, can you guess between what and what angle should phi value lie? If it is between mean and extreme at t is equal to 0, can you guess what should be the value of phi between? Yes, it should be between 0. Mridmay, we are conducting Menti quizzes, my dear kid. Okay, so instead of drills, we are conducting Menti quizzes and we are giving you homework. I hope that clears your doubt. Yes, it should be between 0 and 90 degrees. Correct. Why? Because when it is here, phi is 0. When it is here, phi is 90. So somewhere between 0 and 90, when the particle on that circular path, if it is somewhere here, then the projection will fall somewhere between them, and as that particle goes towards the right side, you will see this particle on the SHM diagram will also go towards the right side. Correct. No, Mrinmay, they are not less. Understand that we are going to cover a lot of problem series. Alright, so there are going to be a lot of problems and there are going to be special series before the exam. Do you have faith? If you have faith in us, then just follow everything. Don't worry about things. So these are all, jamelas. You will just get, involved into this. Understand? Okay. So similarly, if I tell you that the particle is here and it is going towards the left side, somewhere between mean and left extreme, and it is going towards the left side, what will be the value of phi between? What is the value of phi between? What is the value of phi between? Between something and something. What do you think? What do you think? Yes, 180 and 270, guys. Be careful. It is going to be between 180 and 270. Why? Because when it is at the mean, then going towards the left side, then what is the value of phi? It is 180. And if it is at the left extreme, it is 270. So imagine if on the circular path, the particle is here, the shadow will fall here, and the projection will be going towards the left side. So that's why it will be between 180 and 270. Correct. Correct. I hope this is clear. Very good. Very good. Very good. Now, imagine, let's take another question. Okay. Imagine that I tell you this is a particle performing SHM, this is the mean position, this is the right side, this is the left extreme, and I tell you that there is one particle which is at the mean and it is going here. I know the value of phi will be 0. Correct? I know the value of phi will be 0. Now imagine there is another particle which is over here but going towards left side. Then the value of phi will be pi radians. The value of phi is 0 for a particle at mean going towards the right, and the value of phi is pi for a particle going left. Now if I ask you, guys, what is something called as the phase difference? What was this phi? This was phase constant. So phase difference will be the subtraction of both these values. So if this is phi 2 and if this was phi 1, then the phase difference, guys, will always be modulus of phi 2 minus phi 1, whichever is bigger, put it first. So it will be pi minus 0, so it will be pi radians. It will be pi radians. So you are a little bit late. Now, rewind back and you will understand. So guys, what does phase difference tell you? See, on the circular diagram, things will be even more clear. This red particle, okay, this red particle on the circular diagram will be on the top, whereas this particle, this blue one, will be below, and the angle between them will be 180 degrees or pi radians. Now, as these particles move, they will look like this. They will be always at diametrical opposite points. So think about it. On the SHM diagram, when the red one is going towards the right, blue one is going towards the left, they both will go like this and like this, like this and like this. They are doing exactly opposite motion. You can see that clearly. That's what will happen. The red shadow will go towards the right side first. The blue shadow will go towards the left side first. That's what will happen. All right. I hope this is clear. Everyone? Very good, very good, very good. Prajwal, don't spam. I have not forgotten anyone. Concentrate on the session. All right. Hi Ankit, join in. Now, imagine another diagram. Again, imagine a circle. Okay. Now, imagine one particle over here, another particle over here. This is at t is equal to 0. So, if this is my reference line, then this will be phi 1, this will be phi 2, and this angular difference will be delta phi, which is called as the phase difference. This is called as the phase difference between the SHM. So what it means is, if you look at the projection of these particles, the shadow of these particles, so what you will see, shadow of particle 1 will be here, shadow of particle 2 will be here. You will see shadow 1 will be going towards the right side, shadow 2 will be also going towards the right side. So these two particles will go like this. As these two particles go in the circular path this way, as these two particles go this way, you will see these two particles will follow each other like this. So there is a phase difference between them called as delta phi. I hope this is clear. I hope this is clear. Yes? This is the phase difference between them. Now, just imagine both the particles go back and forth simultaneously. So you have one SHM here and another SHM here. This particle is also going here, this particle is also going here. Both of them stop and come like this and go like this. Then can you guess what is the phase difference between them? Can you guess what is the phase difference between them? Mr. Perfect, you will be blocked if you spam one more time. And by the way, this is not an Hindi channel, this is an English channel, understand that? So please don't spam out here. Okay. Yes, it will be 0. Very good. This type of arrangement is said to be in phase. So these two SHMs, alright, these two SHMs are said to be in phase, remember that. Similarly, if there are two particles which are exactly doing opposite stuff, exactly, when this is going here, that is going there, when this is going here, that is going there, opposite stuff, then the phase difference will be pi, and then they are said to be, these SHMs are said to be out of phase. Very, very important terms. Yes, Saurav, correct. At least you want to spam in English here. Good one. Okay, very good. Excellent. Now you will be like, sir, what is the use of all this? I'll come to that. Don't worry, I'm going to come to that. I want to show you one more beautiful thing and then we'll start solving problems. Imagine this is my phasor diagram. This is called as phasor diagram. Now, what is a phasor diagram? If you have a SHM which is going back and forth, okay, it is going back and it is going back and forth like this with some amplitude. This is the mean position. There is always a visualization which you can create that is called as a phasor diagram. It's just an hypothetical thing. Remember, if a spring mass system is oscillating, you can always visualize, oh, probably it is the projection of this circular motion. That is called as phasor diagram. That thing which will rotate is called as the phasor. What is it called? That thing is called as the phasor. And that angle which it makes, we just discussed, that angle which it makes, that angle is called as the initial phase angle. Remember that. That angle which it makes is called as the initial phase angle. Now, also one last thing. Okay, this is called initial phase angle which it makes at t is equal to 0. Now just think about it. After some time when it comes here, that total angle which it makes, that total angle with the reference line which it makes, that angle is called as just the phase angle, and that is nothing but phi plus omega t. Understand that. So now you will be understanding why it is called as the initial phase angle when it is at t is equal to 0. Because when you put time as 0, the phase angle will just become phi. That's why it's called as the initial phase angle. I hope this is clear. I hope this is clear. Okay, interesting. Interesting. Okay, very good, very good. Now let's start solving some problems. Let's start solving some problems and see how things go. Okay. Okay. So a lot of stuff we have learned. So by the way, this is how it looks like. Oh, by the way, the diagram that I have drawn over there previously was for a sine omega t. Understand that. But this diagram, when you take this as the reference line, earlier this was the reference line. If you take this as the reference line, then the value of x that you will get will be in terms of cos. So if you are using cosine graphs, then measure everything from here. And if you are measuring or you are writing sine graphs or sine equations, then measure everything from this vertical line. So keep this in mind, guys. Yes, excellent, Vishwajit. Yes, wave is also SHM. That's why I said this is very important for waves. That's why I didn't start waves first. I wanted to start SHM because this is very important. Correct. Yes, and SHM is a very important chapter for everything. So let's do this. What is the phase constant of a SHM? Okay, if initial speed is half the maximum speed and the particle is moving towards the right extreme. If the particle is moving towards the right extreme and if initial speed is half the maximum speed. Let's do this without using too much of equations. Okay, without using too much of equations. Let's see how do we do this. Now just imagine if I draw a phasor diagram of the corresponding SHM. So let's try to do this. Let's try to do this, guys. Come on. This is the mean position. Okay. This is also the origin. The particle is having half the initial speed and the particle is moving towards the right extreme. And let's assume it is on the right side. Okay. It's towards the right side. What is the phase constant? So I think the particle is here and it is moving like this. Correct? It is moving like this. I hope everybody is understanding it. Yes. Now, what is the way to solve this? Think what should be the particle or where should that particle be on the circular diagram so that the projection falls over here. The particle should be over here. Correct? The particle should be over here so that the projection exactly falls over here. Excellent. Everyone fine till here? Now, this is where the particle is at t is equal to 0. And now, think about it. If I draw a phasor like this, won't this angle be phi? Won't this angle be phi? Okay. in the first quarter. Now think about it. This particle in that circular motion will also have a tangential velocity, v tangential. And how much will be the tangential velocity? Tangential velocity is, remember, circular motion, r omega, v is r omega. So here r is a and omega is omega, so it will be a omega. I hope this is clear. That's the v tangential velocity. Now think about it. The horizontal component, this component, will be exactly equal to this, because this is the projection, right? This is the projection. So this velocities, this component will be exactly equal to this SHM's velocity at that instant. This will be exactly that velocity at that instant. Yes, and it is mentioned that this velocity is half the maximum speed, and we have seen in our previous lecture maximum speed is a omega. We have seen this. So the speed of the SHM should be a omega by 2, guys. The maximum speed of the SHM should be a omega by 2. So that means this component must also be a omega by 2. Everybody getting it? This component should also be a omega by 2. Now think about it. If this is a omega by 2, can we use some geometry? I think so. I'll tell you what. This is fine. So even this will be fine. Come on, they are opposite like this. So these are two parallel lines. This is fine, this is fine. Now if this is fine, won't this angle be also fine? Think about it. Won't this angle be also fine? Think about it, guys. Everyone seeing it? Everyone seeing it? All right. Everyone seeing it? This angle should also be phi, because this is phi, this is 90 minus phi, this is 90 minus 90 minus phi, which is obviously phi. Now, can you guess it? Come on, guys. This velocity is, this component is a omega by 2. So it is just saying v tangential's cos phi component is that velocity in that x direction, which is a omega by 2. And how much is this? This was just a omega. So guys, isn't cos phi equal to half? Isn't cos phi equal to half? So what should be the value of phi then? Think about it. It should be 60 degrees, which is pi by 3 radian, and we have got it. Yes, Pragya, I do remember you. Join in. Is that understood? That's how you can solve questions using phasor diagram. Now it took a lot of time because I had to explain it to you. But understand, if I had to just solve it without explanation, this can be done with practice within around like maybe 30 seconds, max 45 seconds. Understood that. Understood that. I hope you guys have understood that. Okay. VK and Shreyas, calm it, guys. Don't fight. Keep calm. Don't fight. Alright? VK, last chance, don't fight, and no bad words, no abuses, nothing at all. Alright. Okay. So, cool. Let's get going. Okay. So, let's go to the next question. Here's the next question. Let's see how many of you get this. Come on, if you get the answer, just post it up. The displacement of two particles executing SHM are sine omega t and a cos omega t plus phi. So these are the equations of SHM of two particles executing SHM, but they are in the y-axis. Doesn't matter. It could be x also. The phase difference between them, now doesn't matter. Phase difference between velocities, phase difference between acceleration, phase difference between positions, all mean the same thing. So guys, think about it. Okay. Fine. Come on. Okay, a lot of you are saying D, some of you said C, some of you are saying A. So, well guys, well. I'll reveal the correct answer. Okay, come on guys, focus. Okay, so the correct answer is, let me tell you. First of all, y1 is sine omega t. just that. There is no phi in that. That means it is plus 0. It's as good as putting 0 over there. What is y2? y2 is a cos omega t plus phi. Now be very careful. Most of you would have forgotten that there is a cos, not a sine. So that creates a big difference. That creates a big difference. How can you convert cos to sine, sine to cos? Come on, pi by 2. You would have learned this in trigonometry. So this will be a sine omega t plus phi. Okay, so plus phi plus pi by 2. Remember guys, you would have learned this. Sine of theta plus pi by 2 is equal to cos theta. You would have learned this. So here theta is this term. So sine of this plus pi by 2 will be cos. That's it. Now things are easy. Now things are easy. Just compare guys. Here you have 0. Here you have phi plus pi by 2. So guys, what is the phase difference? 0, phi plus pi by 2. Obviously it should be phi plus pi by 2. The catch was that cos. A lot of people forget that cos. Chain smoker, I would love to but you're a little bit late by around 4 years. Otherwise definitely I would have married. Okay, so I'm already married. Okay, chalo. So let's get going to the next question. So here is the answer guys, phi plus pi by 2. Arey Shreyas, don't worry yaar. Come on, chill Shreyas. Come on, calm down, forget it. Be friends yaar, chill. Concentrate on the session. Alright, chill. Alright. So let's get going. Okay, so here is the next question. Very good question. Read it for some time. Get a hang of it, what it means. Yes, answer is whatever. Arey VK, my god, VK, I'll chat with you later on Instagram. Don't cry. Please don't cry, VK. You should be all happy. Come on. I cracked such a nice joke now. Don't worry. Nobody is telling anything. Okay? Calm down. Chain smoker, next janam, okay? But actually not next janam, yaar. Already I promised my wife for sato janam ka rishta and all that. So maybe 8th janam, okay? All right, let's see what you guys say. Arey Asmi, even I am a rising star, yaar. Aisa kyun? Oh my god, Krito, probably I don't know what to do with that. Probably should consult a doctor. I don't know much about bio. Okay. Okay. Shreyas, last warning, you cannot talk like that to any minion out here. You cannot talk like that. It's a matter of concern for everyone because everyone is in this chat and we are all a family, we are all a minion family. So we will definitely interfere if somebody hurts somebody's feelings or if somebody is feeling bad or anything. So if somebody has said something, so like Khushbu, so it's because she feels belonged out here. So Shreyas, don't say such things. Okay, so let's see what's the correct answer and oops. Okay, wait. Let's see how to solve this. Okay. Now, it is mentioned in the question that there are two SHMs, same amplitude, same frequency, same line. The maximum distance between them is root 2a. The maximum distance between them is root 2a. Okay. So, let's try to visualize not by SHM diagram because it's very difficult to predict when will these two particles have maximum distance. It's so difficult and I have seen so many books, so many people solving via derivatives, maxima, minima. My goodness, it's so scary guys. Don't do it using maxima, minima. That's not needed. I have taught you phasor diagram for a particular reason. So let's use that. So let's draw a phasor diagram. This is my reference line. This is my horizontal line. Now just imagine those two particles are there like this. They are moving like this. Their shadows will be falling on the horizontal line. Okay. When or where do you think these two particles on the circular path should be, so that their separation is maximum. So let me give you some clues. Imagine one particle is here and the other particle is here. In fact, both their shadows will fall at the same point. So I don't think their separation is maximum. Correct? So obviously their separation is not maximum. Take some other point. Let's say one particle is, let's say, here and the other particle is here. Okay? So the maximum distance between them is root 2a. Okay. So think about it. First person's shadow will be there only. Second person's shadow will be here. Correct? Now this is the maximum distance. But think about this. What if, okay, what if one particle is here and another particle is here? These are the two phasors, and think about their projections, guys. Think about their projections like this. This is projection of point 1, this is projection of point 2. Don't you see their distance of separation is maximum? Because after this, as they both rotate, this distance will definitely reduce. This difference will definitely reduce. VK, come on. I hope you are happy now. Yes, Pragya, for sure. Yes, this distance is maximum, because anywhere else you can see the distance is not so maximum, because as they go, you will see that the distance between them will keep on reducing. So that's why this separation, can I call this as root 2a? Can I call this as root 2a? Now, if this is root 2a, think about it. What will be this distance? What will be this distance? Half of root 2a. So what is half of root 2a? Half of root 2a, guys, it is nothing but a by root 2, isn't it? It's a by root 2. And what is this green line? The green line has a length of a. Remember, radius equals the amplitude. Acha, now I got it. Yeah, this is a by root 2. Arey, come on, this angle is very obvious now. Guys, what is this angle in this right angle triangle? This is a by root 2, this is a. Can you guess what's the angle now? Exactly, Aishwarya. Exactly. This angle should be 45 degrees. Exactly. Come on, very good. Okay, this is enough. Okay. Okay. So you have been put on timeout, I guess. Okay, so this is 45. If this is 45, this is also 45. And if this is 45, this is also 45. So guys, this total angle, how much will this total angle be? 90 degrees. So that's the answer. What is the phase difference? The answer is pi by 2 or 90 degrees. Exactly. I hope this is clear. Okay, great. Chalo, let's get going. Oh my God, you kids are really kids, guys. How you guys are fighting amongst each other. First time on YouTube, I'm experiencing this. And calm down, guys. New Year time, chill out, thoda masti karo, make friends. Come on, minions. Yes. And look at that, chain smoker is really pissed because I didn't accept the proposal. All right. Okay. So now next thing, energy of a SHM. What is the energy of a SHM? So there are two kinds of energies when a particle goes back and forth like a spring block system. It will have two kinds of energies. It will have potential energy, which is stored in the spring, and it will also have kinetic energy because the block will have some velocity, guys, isn't it? So let's see what those energies are. So let's say I want to talk about the potential energy. The potential energy will be the spring potential energy, which is half kx square. So guys, think about it. What is the value of x? Oh, I know it. It is nothing but a sine omega t plus phi. Just square it. So sine square and a square. So that is potential energy. So potential energy can be found out in terms of x, or if you want, you can also find it in terms of time. If time is given and potential energy is asked, use this. If x is given, potential energy is asked, or vice versa, use this equation. As simple as that. Next, kinetic energy. Kinetic energy will be half mv square. Now what is the velocity? We have already seen it is a omega, correct? So first let me put that m. Oops, 1 second. It is half m. Okay, v is nothing but a omega cos omega t plus phi, but I have to square it because there is a square out here. So that is kinetic energy, but I can use some small modification out here. Remember, omega was root k by m. So guys, square it. So you'll get omega square m is equal to k. So just square this, you'll get it. So you have m over here, you have omega square over here. So you can just write it as half k a square cos square omega t plus phi. Alright, so this is nothing but kinetic energy. This is nothing but kinetic energy. Okay, I hope this is clear. I hope this is clear, everyone. I hope this is clear. Okay, so now what do you think will happen if I add this potential and kinetic? I will get the total energy. The total energy will be potential energy plus kinetic energy, guys. Now think about it. Half k square, bottom and top. Sine square, here you have cos square. What is sine square plus cos square equal to? It's 1. So what will you get? You will just get it as half k a square. Now isn't k a constant and isn't a constant? That means the total energy will be a constant, guys. As simple as that. Yes, sine square plus cos square is 1. Excellent. Very good. So this is the total energy. You should remember all these things. All these are important stuff. Okay. So going to the next thing. Look at this, guys, how potential and kinetic energy changes as the particle goes back and forth. Observe each point carefully. I'll leave you with this animation for some time. Observe this carefully. When it is at the leftmost or the rightmost, the potential energy is maximum. And when it is at the mean position, equilibrium, the kinetic energy is maximum. You can see that. You can see that very clearly. But the total sum, the mechanical energy will remain constant. You can see that very, very easily. Very important. Very important animation. Alrighty. Now, if you plot all of them in the single graph, this previous one, please understand, it was just potential energy, correct? This was just potential energy, but if you plot all of them in a single graph, the green one is the potential energy graph, the blue one is the kinetic energy graph, but their sum, the red one, is the total energy graph. So you can see as kinetic energy, kinetic energy increases, potential energy decreases, but their sum remains constant at a value of half k amplitude square. So this is how the graph exactly looks like. Remember this. I hope this is clear. Okay. And guys, yes, do not forget to hit the like button if you have not done it already. Show some support and love, guys. Yes. Okay, let's do a question, guys, on this. So there is a SHM having amplitude of 4 meters oscillating in the x-axis with the origin as the mean position. At what value of x is the kinetic energy equal to the potential energy of the spring mass system? What x value is the potential energy equal to the kinetic energy? Yes, you have seen this graph before too in work power energy, correct? Okay, let's do this. You are free to do, Ronak, whatever you want, right? Don't worry, even if you dislike the video, I'll still love you because I'm here to teach you, alright? Okay, so now the SHM has an amplitude of 4 meters and it is oscillating in the x-axis. Where is the kinetic energy equal to the potential energy? Okay, now the moment potential energy equals the kinetic energy, think about it, both are equal in nature. Can I say the total energy is half is exactly equal to the potential energy, because potential energy and kinetic energy are equal, their sum should be total energy. So half of the total is potential, half of the total is kinetic, isn't it? Isn't it? Yes. Okay, so now think about it. What is the formula for total energy? The formula for total energy is half K A square. Correct? It is half K A square. What is the formula for potential energy? It is half K X square. Oh, the best part, K goes, half also goes, only one half remains, and it will become half A square is equal to X square, guys. Half A square is equal to X square. Excellent. Now, just think about it. X will be equal to A by root 2. And what is amplitude? Amplitude is 4. So it will be 4 by root 2 meters. That's it. That's the answer. Very simple way. There are many more ways, complicated ways to solve the question, but this is the easiest way, I suppose. Yes. I hope this is clear. Correct. You can rationalize it if you want to. Yes, you can do that. Up to you. Okay, great. Let's get going to the next question. Oops, I think the answer for this already came out. Okay, probably you can take it up as homework now. Anyways, the displacement of a particle, I'll just tell you how to solve this. The general idea. This should not have come, the answer, but anyways. The displacement of the particle of mass so and so grams is given by this equation in SI units. The kinetic energy of the particle at a point which is at a distance of 1/3 of its amplitude from its mean position is how much? Okay, so the question is find the kinetic energy of the particle at 1/3 of its amplitude. Okay, so what we can do, guys, there is a very simple way to do this. I'll just tell you the method, you can get the values. Since kinetic energy is asked, can I say kinetic energy is total energy minus potential energy? Obviously. Now what is total energy? Total energy is half K A square, correct? And what is potential energy? It is half K X square. Okay, now think about it. I can take half K common and this will become A square minus X square. But hold on, I already know what is the value of K. I just told you omega is root of K by M. I just told you some time back. So K is nothing but M omega square, correct? K value is M omega square, and this is nothing but A square minus X square as it is. I've just taken things common. Now, everything is known, guys. Mass 3 grams, omega is 0.2. Remember, omega is 0.2 over here. You can see this. M is 3 grams given. A amplitude, oh, that is indirectly given. Okay, so see, amplitude is 3 over here. So this amplitude is 3. So 1/3 of its amplitude. So it will be nothing but 1 meter. So 1/3 of 3 is 1 meter. Just solve this and you will get the answer as 0.48 into 10 to the power minus 3 joules. Do not forget this is grams, so convert it into kgs. Alright, I hope this is clear. Okay, is this clear, everyone? Great. Chalo. Oh, I think the answer slide was before the question slide was later on. Okay, anyways, I just told you how to solve this. Now, I want to solve this beautiful question with you. Now, remember, last lecture I told you, whenever there is a constant force, it does not matter. The time period of SHM is not dependent on the constant force. In fact, it's only the mean position which shifts. Like if you take a spring block system which oscillates like this, if you make it vertical, it will still oscillate, but instead of oscillating about the natural length, now there is an already extended position, equilibrium position has shifted, so it will oscillate about that new position down there, and that shift is mg by k or constant force by k. That's what it is. The time period is still 2 pi under root m by k. That's what I have told you. Now, over here, you would have experienced this. Imagine a block of log is floating in water and you push it gently. It goes up and down, up and down. You would have seen this. And if you have wondered what is the time period and how do we calculate it, today you're going to learn how the time period of oscillation of a block floating in a liquid is found out. So let's see, very interesting question out here. So density of the block given, density of the liquid given, as shown in the figure, find the time period. Anything else which will be needed will be assuming those variables. Okay, so let's have a look at it. This is the side view. Okay, this is the side view, guys, of this diagram. This is right now at equilibrium. Do you see there is some liquid which has been displaced because that solid is submerged in this liquid? So the volume which is submerged is also the displaced fluid, and there will be a buoyant force over here. There will be a buoyant force because of this fluid. That buoyant force is exactly balanced by which force? Mg force. So that buoyant force and Mg force are balanced. That's why that block is floating in that liquid. Now, I don't know. Let's see how buoyancy is included, Razik, Akansha. Don't worry, we are going to see that. Now, understand what will happen if I push it little bit down and it is oscillating back and forth. This is some random position. Think about it. This was the liquid displaced before. Okay, this was the liquid displaced before, but oops, I think it went off. This was before, and this is the liquid displaced now in the random position at some instant of time. Do you see there is some extra fluid which has been displaced? That extra fluid which has been displaced, that extra fluid will create extra buoyant force. It will try to push it back because you have pushed it down. That will act like the restoring force. That will act like the restoring force. Shreyas, I am not doing anything. Understand, I am teaching out here. Okay, so now think about it. If that is the situation, the restoring force, if I say, is because of the extra buoyant force. It's because of the extra buoyant force. Think about it. How much will be this extra buoyant force equal to? It will be equal to extra volume which has been displaced into density of fluid into G. Remember, V rho G is the buoyant force. So extra buoyant force will be extra volume into rho G. Yes. Now think about it. What will be the extra volume which has been displaced? Let's assume this is X. And the area of cross section over here, this area is A. Then that volume will be AX and this will be rho G. Correct? That extra volume will be area into X. Now just rearrange and you will get this as rho AGX. Don't you see that force is proportional to X? Don't you see that force is proportional to X? Yes. Now what does this tell you? This is same as K, guys. This is same as the spring constant. So simple now. The time period will be 2 pi under root. The moment any force is proportional to X, that constant is like the spring constant. Remember that. So basically this will be 2 pi under root mass by this entire thing K, which is rho AG. That's it. But if you don't like this mass and you want to put the cube's density somehow, then also you can simplify this further, because mass is density of that cube. What is that density? Sigma into the volume. So let's assume the total height to be h. The total height of the cube is h. So then the volume will be A into h. Correct? And this will be rho AG. AA goes and you will be left with 2 pi under root sigma h by rho g. That's the answer. Yes, restoring force must be negative, sign convention wise. So where is our displacement? Niche. It's down. Where is the force? Up. So automatically it is negative, just that I have calculated the magnitude of the restoring force. I hope this is clear. I hope this is clear. Okay? I hope that clears all the doubts. Hi Carrie Minathi, join in. Don't spam. Alright. So let's look at the next thing. Oh, by the way guys, for all those of you who want to enroll into the pro subscription where I teach a lot of micro courses. So guys, a lot of you are asking, sir, we want to do more problems, do everything on YouTube. Guys, understand, it doesn't work like that. Everything just can't be done on YouTube. There is a numerical course I'm running. There is a HC Verma discussion course I'm running. There is there are a lot of other courses which we are running. A lot of other teachers are also running a lot of micro courses. So it's not just about micro courses, guys. It's that you are going to get yourself enrolled into long-term regular batches with tests, with assignments, and you will also get doubt solving. You will also get, two teachers during the class. One is the main teacher who is teaching you, another teacher assisting you with the doubts, and so many other things. So guys, understand, if you want to enroll yourself for maybe you are in 11th, maybe you are in 12th, maybe you are a dropper, all the details are mentioned in the description link below. You can check it out, the prices, everything. Just check out the link and use this coupon code. Only then you will get 20% off on that price. SHHPRO is the coupon code. So check it out guys, because understand that these pro subscription is meant for all the 11th, 12th and dropper students only. Understand that. And you get all the things like doubt solving, questions, assignments, test series. You don't have to run anywhere. KVPY is also there. There is board examination also which is covered. Board related batches are also there. If you are interested in Olympiads, there are Olympiad batches also. Everything is under the same price. No extra fees for anything. Remember that. Okay. Chalo. Now let's come to the last part of today's session. Let's come to the last part guys. Come on. Princey, yes, you can take it for 1 month and you can try it out. No problem. It's beneficial. Definitely. And if you feel comfortable, then go ahead. You can take it for 3, 6, 12 months, up to you. Yes, definitely you can take that. Okay. All right. So let's get going. Mrinmay, I will ask you the same question when you are old. Okay. So then I'll see what your answer is. I'll definitely love to hear that. Okay. So a lot of channels so-called provide free content. Surely it's really good. Go ahead. You're free to attend any channel that you like. All right. Definitely you're free to attend any channel you like. Okay. Cool. So let's have a look at the last part of today's session, where we are going to see the relationship between force and energy. We have already seen this in work power energy, guys. We already seen in work power energy that force and potential energy are related to each other by this equation. F is minus du by dx. I hope you remember that. This is a potential energy curve. The slope, the negative of that slope, du by dx is the slope, the negative of that is the force. That force and potential energy are related by this equation, in case you have forgotten. And wherever the slope is zero, du by dx is 0, force is 0. So that's the equilibrium position. That's what we have seen. I hope you remember that. Now let's see, how do you relate SHM and energy? Just imagine, I tell you, the energy of a particle, potential energy, is 7x square, example, plus 3. Just some random energy. X is the position, U is the energy. First of all, think about it. How will the graph look like? It will look like a parabola. The energy is like this. This is your equilibrium point. Now, if I move the particle here or here, So what will happen? It will try to come back and it will oscillate back and forth. It will oscillate back and forth if you displace it from the equilibrium position. That means I can find the time period. And how do I find the time period? Very simple. Just figure out what is that force acting on that particle, and that will be minus du by dx. So take the derivative of this term. 7x square's derivative is 7 into 2x, and 3's derivative is 0, correct? So this will become minus 14x. Now do you see this 14 is exactly like the spring constant? This 14 is exactly like the spring constant. Very good. That means I can now find the time period. So that will be 2 pi under root m. Oh, the mass should be given. Let's say the mass was given to be 2 kg. Example. So then the time period will be mass, which is 2, by k. K is 14, and that's it. It will be 2 pi by root 7 seconds. That's it. That's how you can find the time period if energy is given. That's how you can do it. Mrunmay, if you have patience and if you have faith, believe me, once the flash series is over, in the month of April or around, we are going to start batches for 11th and 12th separately, and that will run year long, and we'll be providing all the content. So hold on. My dear minions, understand, right now we have to complete the portion by February because your exams are going to be there in schools, colleges and boards and God knows what. So understand that. Mrunmay, everything you want everything for free, you want more questions, you want this, you want that. Understand, how can you do everything in 5 minutes? How can you do? Think about it. Is it possible? You only think and tell me. If somebody is doing it, I'll really be happy. Please go ahead. Okay? So guys, stop complaining, stop whining this way. It really is disheartening to see when we put in so much of efforts, when we are trying to do as many things as possible. These kind of things are not really good. This kind of comments, it's not really heartening to see all these kind of stuff out here. Okay, so anyways, but I'm still going to continue doing whatever I'm doing. Okay, don't worry, I'm going to provide every content, whatever I have to you guys. I know a lot of people don't provide the tricks or the shortcut tips and all that, and many other things. So guys, I'm not going to do anything like that. Okay, now imagine u is given as 6x square plus 2x minus 3, and the mass is given to be something like 4 kg. Example, find the time period. Let's say we have to find the time period. Let's see how do we do this. The first thing, find force. What is the force? Minus du by dx. So this will be minus of derivative of 6x square. What is the derivative of 6x square? It will be 6 into 2x. Derivative of 2x, 2. Derivative of 3, 0. Now rearrange this. So this will become minus 12x. Oh, that will become minus 2. Now guys, think about it. There is minus something into x and some additional term. Now this is a reason of worry. That what do we do with this constant? Should we be really worried about this minus 2? Should we be really worried about this minus 2? Think about it. Think about it. I don't think so, because it's a constant force. And remember, constant force can't change the time period. So don't really worry about this, because this is just a constant force. This 12 is as good as K. Spring constant. This is as good as K. That means I can immediately find the time period. This minus sign just denotes that the force is restoring in nature. So time period will be 2 pi under root m. M is 4, K is 12. So that means it will be 2 pi. 4 by 12, guys, 3. So it will be 2 pi by root 3 seconds. So guys, this is how you find time period using energy. Excellent. Thank you guys for all the support. Thank you so much for all the love and support. that you guys are showing. Thank you very much. Okay, so you can solve these kind of questions as well. Find the time period of oscillation. This will be put up as homework. I think so. I think a similar question was there in the homework. So guys, this is your homework question. Just think about it, how you're going to solve it. Now the last thing which you have to do today before we end is something called as the differential equation. Now let me tell you what is a differential equation. Not many people know much about differential equations, so don't worry, I'll tell you from the basics. Just imagine I have an equation like this. 6x plus 2 is equal to 0. Okay? And I tell you what is the value of x. You can immediately figure it out. So you'll just be like, oh, 6x is minus 2. Therefore, x is minus 2 by 6, which is nothing but minus 1 by 3. So this was an equation, and this was the solution of that particular equation that we had. Correct? Now just imagine, instead of 6x plus 2, if we had 6 dx by dt plus 2 is equal to 0. Now this is called as a differential equation. Okay, this is called as a differential equation. Now understand, I can rearrange this. I will get dx by dt as minus 1 by 3. Now I'll be like, sir, what is the solution of this? Well, hold on. Just rearrange it further. You will get dx is equal to minus 1 by 3 dt. Why did I do it like this? Because I can integrate. Yes, I can integrate, guys. And if you integrate dx, what will you get? You will get x. If you integrate dt, what will you get? T. So one constant, because I did not put any limits. Now what is this? Is this a value like I got over here? No. In fact, the solution of the differential equation is a function. Yes, the solution of a differential equation is a function. So guys, this is the main difference between normal equation and differential equation. A normal equation gives you a value or values. If it's a quadratic, it will give 2 values. If it's a cubic, it might give 3 values. But a differential equation gives you a function as the solution. All right. Now, if that's the case, what's the differential equation for a SHM? The answer is very simple. Remember, I told you the force of the spring is minus kx, and this force is mass into acceleration. So obviously, ma, bring that kx on this side, it will look like this. Now, what is a? It's the second derivative of x. So it will look like this, m, second derivative of x with respect to time plus kx is equal to 0. So this is nothing but your differential equation of SHM. This is the differential equation of SHM. Now, if you have understood this, you will be like, sir, what is the solution? What is the solution of this? Guys, you already know the answer. You don't have to break your head and integrate. Guys, the equation is x is a sine omega. Omega is root k by m. T plus phi. This is the answer. This is the solution, because this root k by m is nothing but omega. That's it. You don't even have to worry about it, because using this only you have got all of this. Understand? So this is the solution of this differential equation. Okay, is that clear? Is that clear, everyone? Now how do you use this in questions? How do you make use of these, and how do you solve questions based on differential equation? So look at this. Now you might be worried about, sir, what is this double dot? Guys, this double dot stands for second derivative. So if there is a single dot, it's single derivative, double dot, like second derivative, 3 dots, triple derivative. So the question is, the equation of motion of a particle, differential equation is given, x double dot plus 64 pi square x is equal to 0. Then in the equation, okay, so then find the time period of SHM in seconds. How do we do that? If you want to start solving, you can start doing it, but I'm going to solve it for all the people who are stuck. Don't worry, I'm going to solve it for you. Now, look at this equation and compare it with differential equation of SHM. mx double dot plus kx is equal to 0. isn't this the differential equation for SHM? Now if you compare this second, this is nothing but d square x by dt square. Understand that. If you compare, you will immediately understand how do you find the time period, because time period was 2 pi under root m by k. So therefore it will be 2 pi under root. Instead of m, you have 1 because there is nothing getting multiplied with x double dot. But k, you can see what is similar over there. It's 64 pi square, guys. It's 64 pi square. Now think about it. This is nothing but 2 pi root of 64, guys. What are you going to do? What is the root of 64? 8. And what is pi square? It is pi. So it will be 8 pi. Pi by 2 by 8 is 1 by 4. And that's the answer. Okay. A option should be the answer. Correct. Correcto. Excelente. So this is how you can use differential equation to solve a question. And that's the answer. Excellent. So these are our stars who have been posting answers for all the solutions, all the homework questions. The solutions will be posted on the Telegram group. Most of it has already been posted. So very good Khushbu, very good Yalni, very good Ankit, very good Khushbu, very good Saurav. Very good guys. And these are your homework questions. You will find it in the session PDF, which is there in the description box below. You can scroll down, you will see all the homework questions. Just check it out. These are the homework questions which you have to solve. Okay, so check that out. Okay, I have put a lot of homework questions today because I want you to get that practice. Yeah, I want you to get that practice. And remember, Ekalavya batch entrance test is starting. So what is this Ekalavya batch? It's a free batch. Guys, again free. I don't know, somebody was just crying saying a lot of content is not for free, that some of them are economically backward. So don't worry, we are here for you. If you are economically backward also, no problem. Or even if you have money, whatever, it doesn't matter. This batch, Ekalavya batch, is for the 12th standard or the dropper students who are going to attend or attempt the examination in 2021, JEE Advanced. And this is completely free till the end with lots of test series, modules, assignments, discussion, full syllabus, part syllabus, special sessions by AP Sir and Pulkit Sir. And there will be also counseling after the advanced exam before you get your seat. These are the ranks that were produced exactly this year in JEE Advanced, guys. All India rank 41, All India rank 43, and there are so many other ranks. 550 people have cleared advanced examination in this Ekalavya batch. Understand that? And look at the changes that have been produced. Before they joined Ekalavya batch, these were their ranks, and see after joining the Ekalavya batch, look at their changes, guys. So the details of it will be posted. How to enroll, etc. will be posted. Okay, these are all the ranks, guys. Will be posted in the Telegram group. Do check it out. The form you have to fill is this one. This is the form link. It will be also available in the session PDF in the description box today. These are the dates. Mark it in your calendar. You have to take the test on these dates to get inside this batch. Who will be teaching? I am there, Shimon Sir is there, and all the amazing teachers out here at Vedantu. Don't worry, guys. Shreyas, there will be much better questions than Irodov and Krotov. Yes, there will be Irodov and Krotov questions modified in a way. Yes, it will be for NEET as well. Yes, it will be for NEET as well. Definitely. Yes. Okay. So I hope this is clear, guys. The Telegram group link for Ekalavya batch is also mentioned. Please check it out. And I'll be posting out all the details on our official Telegram channel as well. So thank you guys very much for joining in today. And I will be meeting you tomorrow at 2 o'clock and also at 6 o'clock for the live streaming session. Take care, stay safe and stay calm. Do not be depressed. I am there for you. Have faith. We are going to do as much as possible for all of you. Okay? Thank you guys. Bye bye. Have a great time.